Okay, let's do now the second lesson. This is again Engineer Tolentino, and I'll do elimination of arbitrary constants. Alright, now this topic is one way of arriving at an ODE. Right, this is useful because it will give us a feeling of solutions to be expected for a DE. So this means that in one way or the other, we will have a feeling of or an intuition of what might be possibly the solution for a given DE. Now there are rules to be followed in order to obtain corresponding differential equations, okay, for a given solution of the DE. The following rules are essential. Okay, number one, okay, the number of differentiating the given equation is the same as the number of arbitrary constants to be eliminated. So if there are 3 arbitrary constants, you differentiate it thrice. And there are 4 different arbitrary constants, you differentiate it 4 times. There is only one, differentiate it once. Next is the order of a differential equation is the same as the number of arbitrary constants present in the solution. If, for example, you have 2 arbitrary constants, then the equivalent order is second order. If you have 3 arbitrary constants, the order will be third. If you have just 1 arbitrary constant, the order will be first order. And the desired differential equation is free from arbitrary constants. So that means you have to do some elimination here in order for you to get rid of the what? Because the final differential equation must be free from what? From arbitrary constants. Okay. So let's start with, okay, example. In each of the following, find the ODE by eliminating the arbitrary constants. Okay, the first example is y is c1 x squared plus c2x plus c3. How many arbitrary constants do we see? There are 3. So what we do in the rule is we will have to differentiate it thrice. The first derivative is what? 2c1x plus c2. The next derivative is 2c1, and the next derivative is 0. You can stop here, and you notice that our last equation is already free of arbitrary constants and third order. So we have what? We have followed the rules. So this is our final answer already. Okay. So next is we have another y is a e to the 2x plus b e to the minus 3x. Okay. So how many arbitrary constants are there? There are 1 and 2. So that means you are going to differentiate it twice, and the equivalent differential equation must be second order. So, okay, get the first derivative. Y prime is 2a e to the 2x minus 3b e to the minus 3x, and get the next derivative, that is 4a e to the 2x plus 9b e to the minus 3x. And then, okay, after getting the second derivative, okay, if you notice, we have not eliminated yet constants a and b. So we have to do some algebra in order for us to eliminate a and b and arrive at a differential equation that must be what? Must be, of course, be free of arbitrary constants. So, okay, again, this is our first equation, this is our second equation. Our first step is to eliminate, okay, algebraically b e to the minus 3x. And that can be done by what? By, you can eliminate a. How do you eliminate a? Multiply this by what? Multiply this by this one. Multiply this by negative 2 and add to this. That's negative 4 plus 4. So this will be eliminated. So that means this is what? Negative 2y prime plus y double prime. Multiply equation 1 by negative 2 and add to equation 2, negative 2y prime plus y double prime is 15b to the minus 3x. And you notice, if you divide both sides by 15, you will have what? Negative 2y prime plus y double prime over 15. Okay, this is our what? Okay, this is our value for b e to the minus 3x. And to solve for a e to the 2x, you have to eliminate b. So to eliminate b, you have what? Equation 1, okay, times 3 Alright, this should be eliminated there. Okay, so this one equation is, if you multiply this by 3, that is negative 9 plus 9, this will be eliminated. So this will be give you what? 3y prime plus y double prime is, this is 3 times 2. 3 times 2 is 6 plus 4 is 10. So 10 e to the 2x, and solving for a e to the 2x, you have divide by 10, 3y prime plus y double prime over 10. So this gives you the, alright. And then you have b and a already, a. So we can use the original equation. This is our original equation. You can plug it automatically there. So plug it there, and plug it there. So it gives you what? 3y prime plus y double prime over 10 plus negative 2y prime plus y double prime over 15. And then if you multiply that by what? By 10, you have 30y is 9y prime plus 3y double prime, and then multiply this by 15, or rather by 30, magiging 30 divided by 15, that's negative, okay, that is 2, so this is negative 4y prime plus 2y prime, okay, and then this can be combined, 9y prime minus 4y prime gives you 5y prime, and 3y double prime plus 2y double prime gives you 5y double prime, and dividing by 6, rather by 5 gives you 6y equals y prime plus y prime, and transferring to the left side 6y, you get y double prime minus y prime plus 6y is 0. This is the required ODE. Alright, we can classify this ODE. This is second order, first degree, and this is a linear DE. Okay, so this is now our final solution. Next is, okay, another approach to this problem is using matrix. Now let us what? Let us have, let us have the original what? The original equations. This is the original equation, this is the first derivative, and this is the second derivative. You observe, you can rewrite this in matrix form. Here, this is called what? Okay, this y double prime and y double prime gives you the first row. This gives you what? The second row. This column gives you the third row. And then you can factor what? A e to the 2x and b e to the minus 3x. And what remains is only y double prime, y prime, y double prime, 1, 2, 4, and 1, negative 3, 9. Okay, of course, this is equal to 0, so this must be what? This, this value must also be what? Must also be equal to 0. So the next step is, expand using the first row of y prime, and y double prime. This is the method of cofactors. Okay, so, you notice that this can be expanded using the first row, cofactors of the first row. In order for you to get the first cofactor, delete that and delete that. You get this 2, 4, negative 3, 9. And the next is delete and delete that. You get 1, 4 and 1, negative 1, 9. And then the signs will alternate because the signs of the cofactors here will alternate. And then that y double prime, delete and delete, you get the minor of y double prime, that is 1, 2, and 1, negative 3. And the next step is evaluate the determinant. So this is just 18 plus 12 gives you 30. That is 9 minus 4 gives you negative 5, and then times negative 1 gives you negative 5, and this is negative 3 minus what? Minus 2, this is negative 3 minus 2 gives you negative 5 y double prime, and dividing by what? Dividing by 5 gives you this equation. So you see, this is our final differential equation. This is already the differential equation we have in the last solution. Next is, alright, this is now, how many arbitrary constants do you see? You only see one, a and a here, you only see one. Actually, this is a family of circles which is center at what? Center at A and 0, and radius is what? Radius is A. So, okay, so we differentiate what? We'll just differentiate once. So, first differential, so this is our original equation. The first derivative is twice of x minus a. The derivative of y squared is 2y times the derivative of y is y prime. And, okay, here. And dividing by 2 gives you what? X minus a plus y prime is 0. Next is, you solve for x minus a there in that equation. So we can have negative y prime. And also solve for a in this equation. You will have a is x plus y prime. And we can already use the original equation because we know already x minus a and a. And then that will be free from what? From arbitrary constants. So substitute x minus a and a to this equation. What happens is you have what? Okay, you have negative y prime. Okay, this is of course, and then square there. Okay, square there, and then y squared plus this is what? X plus y prime, and then square. And then simplify. Alright, you have a y squared y prime squared plus y squared is x squared plus 2x y prime plus y squared y prime squared. Notice that this and this will cancel out, these two. Okay, and then the remaining equation is x squared, and then transfer y squared to the right side. You have x squared plus 2x y prime minus y squared is 0. Okay, this gives you the final differential equation. Again, this is just first order, and notice that this is a non-linear differential equation because of the presence of y there, and this is just what? Okay, first degree and non-linear. Okay, next is another example is this one, xa cosine omega t plus alpha, where omega is what? Is a parameter not to be eliminated, so our constants are just a and alpha. So differentiate once and twice. The first derivative is negative omega a sine omega t plus alpha, and the next derivative is negative omega squared cosine omega t plus alpha. If you notice, okay, this is what? This a cosine omega t plus alpha, that is equal to x from there. So okay, observe like that. So that means that a will already be eliminated, and we have already a final answer, that is x double prime t is negative omega squared x of t. Or final answer is this one. Now this is a linear differential equation, second order and first degree. Okay. Next is, okay, this time there are what? There are two arbitrary constants, C1 and C2. So how many times are we going to differentiate? Differentiate twice. You have what? Okay, the first derivative, most common mistake of students is they will just derivative this, take the derivative e to the 2x and derivative of this, and they forget that this is a derivative of a product because of this, both of these are variables. The first derivative is e to the 2x is negative 3z1 sine 3x plus 3c2 cosine 3x there, plus the derivative of c1 cosine 3x times the derivative of what? E to the 2x. That's 2 e to the 2x. And then, okay, this will be important to us now, okay. If you notice that this is repeated in the differential equation with the introduction of the 2. So I just put 2y there, and then this is, okay, the first derivative. Okay, this will come out as the first derivative. So there is still another, okay, we can, okay, once we differentiate y, that's already y prime. There are no arbitrary constants there. The next derivative, okay, Now, note, this will be important to us. If I solve for e to the 2x times negative 3 1 sine 3x plus c2 cosine 3x in this equation, I will just transfer y prime minus 2y. Okay, and then the next derivative now is again a derivative of what? A derivative of a product here. So that is e to the 2x times, okay, that is e to the 2x times negative here, that is negative 9c1 cosine 3x. The derivative of c2 cosine 3x is negative 9c2 sine 3x plus again the derivative of what? The derivative of product again, this times the derivative of that. That's negative 3 1 sine 3x plus 3c2 cosine 3x times the derivative of e to the 2x, which is 2e to the 2x, okay, plus the derivative of 2y here is 2y prime. Okay, now if you notice, okay, there will be one common term, this equation. Okay, this equation will be important to us there. Okay, so next step is what? If you notice this equation, okay, this is what? This is the same as negative 9y because this is the same as c1 cosine 3x plus c2 sine 3x. You can factor out negative 9 lang, and this one is similar to that, so that is already negative 9y plus, okay, plus this one, okay, is repeated there. That's why this is important to us now. This one, this equation, this is the same as, okay, times e to the 2x. That equation is the same as twice of what? Y prime, twice of this value, y prime minus 2y plus 2y prime. And then simplify further, y double prime is negative 9y plus 2y prime minus, okay, y double prime is negative 9y plus 2y prime minus 4y plus 2y prime. And okay, simplifying further, this is y double prime, this is okay, this is negative 9y and the negative 4y, that is 13y, and 2y prime plus 2y prime is negative 4y prime. We transfer to the left, and this will be our what? This will be our final differential equation. Again, this is second order, first degree, and linear D. Okay, that will wind up our discussion for, okay, elimination of arbitrary constants. Okay, and I hope you could subscribe to our YouTube site, differential equations. Thank you and good day.